All right, so just a quick look at two variable equations and relationships. With these, what we're looking at is equations with two different variables. Oftentimes we use just x and y as our variables, and these are things that can be graphed on an xy axis. The xy axis, again, just being our little grid there that we use with the x and y. So there'll be two values that we can plot because we have two different variables, two different missing values. And our focus in this course is just on linear relationships. Those are going to be ones that are straight lines. So examples graphically of some different relationships. A linear relationship would be one that presents us with just a straight line going up or down, straight across, straight up and down. All those are linear relationships. I'm putting arrows on the end of those because those are lines that extend beyond the graph itself. So these are all different variations of linear relationships. So these are all linear. And then just for a few quick examples of graphics of nonlinear, we can have things like a circle. So a circle is not linear. We could have inverse relationships. We could have square root relationships, and we could have exponential relationships. You may have some other higher power relationships like that. So there's a whole bunch of different relationships that you can have, different types of graph. The only ones that are going to be focused on for us is linear. So what's linear versus not linear, and those are some quick examples as well. We need to be able to identify these by looking at the equations. So if we look at some examples of linear equations, a very common one is y equals mx plus b. And now there's a whole bunch of variables there, but m and b are the ones that will fill in. So we'll often see things like y equals 1/2 x minus 7, y equals 3x plus 2, y equals x. And in that case, both of these are missing, but there's 1x, so technically it's a 1x, and we're just adding the 0, so it's the same kind of format. So all these would be linear relations. We could also have them mixed up a little bit. We could have x plus y equals 4. Something like that would be a linear relation. The key here is that we have both an x and a y, and they're both just a plain x and y, so there's no powers associated with those. And if we rearrange this, we could take this and take our x here, move it to the other side by subtracting. We'd have y equals 4 minus x, and you could rewrite that as negative x plus 4. That looks like one of those type of equations there. So these are all linear equations. Things that would not be considered a linear equation would be things like y equals x squared plus 4. Y equals the square root of x minus 2. Y equals 1 over x plus 2. Y squared equals x minus 1. So all these would not be linear relations because this is a squared on the x, so what actually happens, the graph's going to look something like that. With the y equals root x, you're going to get a graph that looks something like that. With the y equals 1 over x, you're going to get a graph that looks something like that. And then with this last one here, the y is squared. The x isn't, but the y is squared. But if we were to rearrange that and get rid of this here, take the square root of the other side, do the opposite operation, and again we have one of those root type graphs. So all of these are not linear. And all of these over here are linear. So our key features is we're looking for a plain y and a plain old x. They can be rearranged on either side a little bit, but they do have to have a y and x so that when you work it around, rearrange the equation and simplify it down, you do get it into that y equals x kind of format. And I don't know if you can quite see that bottom one here, so I'll just tip that down for you. So there you go. So linear versus nonlinear, we're looking at these types of relationships here.